marathon runner moves with velocity as given in the graph below in miles per hour. It says right there, velocity miles per hour. This is time in hours. Using the rectangle shown, estimate how far the marathon runner traveled from time equals 0, time equals 4 hours. Okay, how do we do that? Well, do you realize the rectangles will be how far, which is distance, right? How far somebody runs, that's distance. Okay, why? Well, because when you find out the area of a rectangle, say I do like this rectangle right here. Let me just do this one. So this rectangle right here is, no, good enough, is what? It's 1 wide. And how tall is it? 4. 1 by 4. So it's 4. So the area of this rectangle is 4. 4 what? Well, it's 4 miles per hour, miles per 1 hour. That's right. If you're jogging 4 miles per hour, that means you jog 4 miles every 1 hour. Times, and down here, this is 1 hour. 1 hour. So these hours will cancel, you see, and you'll get 4 miles. You'll get the distance you went. Or you could just say we know that one other way. Distance is rate times time. Remember what's called the dirt equation sometimes? The distance is rate times time. The rate, velocity, that's miles per hour. That's velocity times time. That'll be distance. And we can see it in the units. Miles per hour times hours, right? Because this is over 1. These cancel and you just get miles. So the point is, if we find out the area of these rectangles, we're going to get the distance. Interesting. So this is a velocity. So the jogger, the marathon runner went faster, 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 then slowed down the last hour. And we can get an estimate of the total distance he ran or she ran by just adding up these boxes. What's this one? This one's going to be 1.5. Say it's 1.5, and the width is 1 for each of these boxes. So 1 wide. This one goes up to 5.5 high. This one goes up to 6 high. Right? This box up here is at 6. So just add those up. 1.5 plus 4 plus 5.5 plus 6. And you get 17. 17 miles. So the point of this example is to notice, here's a real practical, because you might wonder, why are we doing all this area under the curve stuff? Like, who cares about area under the curve? Well, here's one of a million real life practical situations in which area under the curve is something important to us. If you're doing the velocity of anybody, this case, a marathon runner, could be a car, could be an engine, could be anything. If you do the velocity versus time graph, then the area under the curve is this times this, miles per hour times hours, hours cancel, is miles, is distance, is distance. So you're getting the y-axis times the x-axis whenever you do area. And the units of the y-axis times the x-axis, hours cancel, is miles, is distance. So that's something practical that we use this for. And so there we go.